I'm going to hand this over to Bruce Bishop, who will be moderating this panel.
Hang on, guys. We'll get there. As Jeff said, yeah, Bruce Bishop from Crosstech Membrane Technology, not to be confused with CoreStech, as we did this morning. Crosstech, we're a fairly new company, but we have a high recovery, high pressure RO membrane module technology. We sell the modules worldwide. We sell systems in North America, but prior to that, I spent 28 years in ceramic membrane development, production, and sales. So this is a topic near and dear to my heart. So today we're going to talk about current and emerging opportunities in ceramic membranes, and we have the all-star panel here of ceramic membranes. So we're going to start off first with an introduction. We're going to start with Roman on stuff bond.
Yes. First of all, something with the microphone. It's a pleasure to be here. My name is Roman Piccolo. I'm work for Southbound Water Technology as a business development engineer. So Southbound Water Technology is a system and technology integrator for custom engineered systems in water and wastewater treatment. So we've been on the market for more than 30 years, starting with the AES, American Engineering Services, transferring to Doosan Hydro Technology, was a part of the Doosan Heavy Industry, and finally got acquired by Southbound Holding in 2017. I'm also representing our sister company today, which is membrane manufacturer, ceramic membrane manufacturer, which is called Itm Water Filtration. This company is based in Saarbrücken, Germany. Sorry for my German pronunciation. It's not the best one. It's Russian German. Happy to be here. Looking forward for a Q&A session.
Thank you. There we go. Next one is Alsys, Sarah.
Yes, hello. My name is Kevin Donahue. I'm Business Development Manager with Alsys. Most of my career has been spent working with polymeric membranes, so I'm very excited to be working with ceramic membranes now. It's a brand new world, new applications, new products, new people, new everything. So it's quite exciting. So I'm employed by Ceramem. The parent company is Alsys. And Alsys is a very interesting company. They provide inorganic materials, including membranes and catalysts. And we like to think of ourselves as solution providers. You know, we want to solve problems for people. We're not just selling membranes or catalysts out of a catalog. We want to know. We engage with our customers to find out what are their most difficult problems, and then we try to tackle them. So you've seen some presentations today that show some use of the products made by Ceramem and Alsys. For example, the produced water in California using ceramic membranes. So we try to focus on the applications where we can provide our customers with the highest value. And I think the future is going to include applications where we recover materials from wastewater. Thank you.
Great, thanks, Kevin. Fantastic. Next up, Sarah Helix.
Hey, good afternoon. My name is Judith Herschel-Cole, and I'm with Sarah Helix. We are actually a nanofiltration ceramic membrane. We highlight that because after saying that multiple times, sometimes people still revert to ultrafiltration. We've been in business for 8 years, and now have commercialized and are seeing exponential growth currently. So we use a DNA template. It's a very differentiating factor in our production, and we can produce now down to about 280 Dalton cutoff. So we're getting a bit tighter through bordering on the reverse osmosis side of the filtration spectrum. We can do a single stage treatment, so we can simplify water treatment systems and provide a smaller footprint, also improve CapEx and OpEx. And we're addressing a lot of different wastewater applications. Some are more niche applications, but also the wider world of high-strength BOD, COD, wastewaters, and organics. And we see high permeability and very low fouling with 99% uptime, and we're seeing 90% recovery. We have, as I mentioned, commercialized our largest system that is now being fabricated, and will be installed late this year, early next year, is 105,000 gallons per day, 400 cubic meters.
Thanks, Judith. It is. Good. I2M, Greg.
Good afternoon. I'm Greg Wood with I2M. I2M is a company, it stands for Innovation to Market, which I heard several times earlier today. We are a wholly owned company by our parent company, Mann & Hummel, which is a global filtration leader based out of Germany. And the idea was that Mann & Hummel was looking to broaden their portfolio, specifically into life sciences and environmental. Some of you are familiar with some of their recent acquisitions of Microdin Nadir and Tricep and some others, water companies. Simultaneously, they were looking to get into ceramics, so they began developing ceramic technology, more importantly, developing ceramic coating technologies. So at the time, they didn't really have a business unit that was dedicated to that. Some of those acquisitions came after the fact. So where I2M came in was they wanted to create a company that could take some of their technologies that they were developing and kind of get them into the market. And so amongst a couple of other products that we have right now, one of our primary focuses is on the ceramic technology. So we're going to continue to grow and work to expand that market, and eventually we look to transition that back to Mann & Hummel. Thank you.
Thanks, Greg. Next we have Nanostone. Michael?
Hello, I'm Michael Shaw from Nanostone Water. Nanostone has been around since the early 2000s, started in a small lab in Germany. Early, our focus was on tough-to-treat waters and niche applications. In the last few years, we've turned our focus to mainstream media markets, and that has been enabled by our launch of the new CM 151 pictured here. This was launched in 2017. We now have 50 references worldwide, up to flow rate capacities up to 14 MGD. We're focused so far on drinking water, industrial markets such as power, microelectronics, and mining. Though we've been focused on those markets, we're starting to expand our focus in targeted fashion for such places such as seawater pretreatment. Our headquarters is located in Waltham, Massachusetts. Our factory is in Germany. We've got technical offices spread worldwide.
Thank you very much, Michael. And last we go to Rauschert.
Yeah, so my name is Tobias. I'm representing company Rauschert. So Rauschert is a family-owned business based in Germany. And this company has over 110 years experience in manufacturing technical ceramics. That's where they're coming from. And around 20 years ago, they partnered up with an institute which is nowadays the Fraunhofer IKTS. And they implemented the brand, which is nowadays the brand Innopor, which stands for all sorts of ceramic filtration, cross-flow filtration. We are well known for our nanofiltration membranes, but we also provide microfiltration and ultrafiltration, so we cover the whole range. And we also provide solutions with modules and partner up with different companies to provide a solution for our clients from the idea to the solution.
Great, thanks, Tobias. So we'll set this aside. we'll leave that there for now. So anyway, so Mandy Singh had an excellent template for, because what we talked about was starting at a high level with market drivers, then going down into more applications. So thank you very much for the intro. Judith, let's start with you. What market, you're out there selling every day with Cerehelix technology. What do you see as the market drivers for your business?
Well, we see the surcharges for wastewater treatment being quite high and unpredictable and increasing. So it's one driver. There's also the value-added concentrates or solvent recovery. So for the concentrates, for instance, we can make an anaerobic digestion system much smaller and much more efficient by feeding a 10 times concentrated BOD/COD solution. So the regulatory environment is typically becoming more and more stringent, and that helps in promoting our technology as well.
Okay. Kevin, what do you guys see?
One thing we see is increasing interest in sustainability. Some companies are using, for example, diatomaceous earth to clarify their process fluids. And I'm working with some companies where, that's basically their only solid waste is the diatomaceous earth. So they're very interested in using membranes to replace the diatomaceous earth. And they can eliminate, a landfill cost, for example. And I think they could also use it as good publicity. They can show how they're being a good corporate citizen by eliminating, this type of waste.
That's an interesting market driver. We've seen that in the past. Now, Roman, yours is a little different because you do both municipal and industrial. What do you guys see as market drivers?
I would say it depends on the area. For example, also we do our operations worldwide. I would say, for example, in China, big market driver is the regulations. They're getting more stringent, so the requirements are getting tighter and tighter. So people require new technologies and new separation technologies. And another one I would say unique applications. So in industrial sector, we have much harsh water, I would say, and ceramic membranes have a great use in this type of application.
But Roman, your format, because all the technologies represented here they're very different, which is interesting. I think you're the only one here doing flat sheet ceramic, right?
Yes, so yeah, that's right. We are flat sheet submerged ceramic system.
And so what about solids content? I mean, I know in prior ones for tubulars and multi-channels, you can go to some solids level, but...
So our advantage is that we're able to handle high total suspended solids. We have a pore size of 200 millimeters, which is bigger than most of the ceramic manufacturers in here. So we're able to handle suspended solids as a pre-treatment to other systems such as RO.
So Tobias, in Einapor, what market drivers at a high level are you seeing in your business?
So we are mostly, or our core business is still the European Union, and their the positive drivers for the market are the regulations, because a lot of companies are bound to a certain level of COD they can discharge or another parameters. So these are the most the positive drivers in the European Union. But it depends. There are other applications, as said, the unique applications where there's a beneficial for the usage of our products for gaining a need or fulfilling a need of our clients and customers.
Okay, since you guys are tied in, Fraunhofer, you talked about in-process technology. What about in-process, not regulatory driven, but in-process market drivers? So inside of food and beverage processes, high temperature water sterilization, anything like that?
Yeah, so you covered it. So we are mostly active not only in the nanofiltration range. So as said, we are also microfiltration and ultrafiltration, and our core business nowadays is still the micro and ultrafiltration range. So we offer with our membranes high flux for clarification, for example, which are quite known and well developed markets. And with the nanofiltration and tight ultrafiltration, we are going into the markets with the drivers of regulations, for example.
Now, Michael, you're similar to Sefbon. You do both industrial and municipal. what are you guys seeing as the market drivers for your products?
Our customers, I mean, the two main drivers that that are driving them toward us is they're starting to look at total cost of ownership, and they're also struggling with dependability. So our customers are coming to us, and they've got plants that are losing capacity, they're pitting fibers, et cetera, and they know about ceramics, but they thought ceramics were too expensive. But with our package and our method of operation, we're providing total cost of ownership that's lower than their alternative, so they're making the switch to us and achieving a peace of mind that they didn't know that it was available to them.
Okay, interesting. Now, Greg, you're a hollow fiber-like ceramic. What are you guys seeing in the marketplace?
So we've been focused on the industrial wastewater market, and we've seen similar types of drivers that the others have mentioned, with the discharge limitations continuing to drive down as far as what's allowable. But also, I would say another big aspect is the water reuse component. I think the cost of water is going up. So as most people know, the cost to dispose of the water is even more than what the cost of the water coming in is. So if you save it on the front end, you save even more on the back end. So that's a driver that we're seeing, that people are looking for ways to not just treat the water so it's good enough to go down the drain, but then once it's there, let's find a place to kind of put it back somewhere in the system. And even more so, you're starting to see a little bit from some of the companies with initiatives to reduce their water usage. So that seems to be driving that water reuse as well.
Okay, just out of curiosity, who's seeing water sustainability decisions outside of economic decisions? Just because they want to be good citizens, the corporate sustainability folks are saying, we're going to do that no matter what. You see that?
I would imagine there's some economic benefit behind those decisions. So yeah, I would have to believe, but that's what I'm hearing from them. But yeah, I would imagine that there has to be some economic benefit from them.
So we'll go back to Judith now. You've seen the market drivers. You've seen, where are you now focused in your markets in terms of applications? And so what do you have today, and what do you see tomorrow in terms of applications for your NF product?
So I mentioned we're focused on high BOD, COD as one area, and solvent recovery. We're seeing applications in food and beverage, soft drinks, meat processing, aquaculture, breweries, distilleries, juices, but we're also seeing them in personal care products with high BOD, high COD wastewaters that we've seen great success in, and where that is decreasing the downstream costs dramatically by decreasing the chemical costs related to treating the COD as it is more extensive down the line. So that's where we've been focused now. I see in the future some new applications that we have that I've worked in the past in my decades of work in this area, but we haven't investigated yet as a company. One is a two-pass RO, being one of those passes, the first pass in a two-pass RO, because we are getting down into the RO range, into the loose RO range with our cutoffs.
Now, since the applications you're talking about are very interesting, but also interesting because if you go in process, is all your work now just wastewater, or are you actually getting into the process things that Mandy Singh and others have talked about getting into?
We have been doing mostly wastewater, but we have some that are processed, for instance, a juice concentration. We're working with a large juice manufacturer that would like to concentrate and for juice concentrate, frozen juices that they haven't been able to do yet. So that's
okay, interesting.
And they're not in the U.S. They're going to be distributing worldwide based on that new opportunity for them.
Okay, good. Kevin?
Yeah, at Elsis, we're focused on oily waters, the traditional metalworking fluids, the produced water that you heard about earlier today. We also provide some products for use in MBRs, external MBRs. The plate and frame has a lot of advantages compared to a tubular membrane on an external MBR. We also are involved, like, for example, in bilge water in the marine industry. We have several different avenues to market. We sell some equipment direct to naval architects and ship owners. We sell other membranes to OEMs who market their own brand of equipment. And then we also focus on process applications, for example, juice clarification, caustic recovery, beverage clarification like tea, coffee, so forth. So,
Do you get any high temperature applications?
yes, I would say the caustic is often a high temperature situation because it's used as a degreaser or a cleaner. We've done some work with acids also where the temperature is high, as well as we're working on the steam-assisted flooding application in oil and gas where that is also hot water.
Of course. Yeah. So Roman, what do you see? Your current applications and where do you see new ones coming from?
Yeah, so if we're talking about the United States, I would say it's municipal wastewater, MBR. Especially if we're talking about the retrofit of more conventional systems where the tanks already pre-exist. For example, polymeric membrane retrofit. It's a big area for us right now. The plants are getting old. And the municipalities, they're looking for alternatives, going to conferences. Unfortunately, in the US, the market is conservative, so people, they need like more proof that our system work, so more like pilot tests or like references, and we have these. So second is we'll continue to follow deep groundwater treatment, arsenic, radium removal, because like our biggest installations are connected with this. So we have like multiple big references in Saudi Arabia, for example. The plant is about to be commissioned. It's, I believe it's 50 MGD. And third one is the desalination. If you take a look at like market reports about the desalination in the Middle East, it's growing very fast, one of the fastest growing applications in the world right now. So I can see in the next 10 years, it's going to be a big growth in the desalination market. And our membranes is a good fit for desal pretreatment.
Okay. So Tobias, what applications are you in and what do you see coming forward?
So as said, we are mostly in the wastewater treatment at the moment, but we are also already in the product stream treatment, so to gain valuable products out of process streams, for example in pharmaceutical applications. We as Rauschert Innopor are focusing, thanks to Professor Vogt, who already shown the pictures, to scale up the membranes and geometries to get down the price, but we are also looking into other technologies and types of ceramic filtration to complete our product lineup, such as the ceramic plates and also some ceramic rotation discs.
Now, everybody so far has talked about water. What about non-aqueous? Have you looked at solvents, oils, anything beyond water?
Yes, we did. We do a lot of tests, a lot of testing with different customers, but it takes a long time from the testing to the solution, and unfortunately it's not a plug-and-play process.
So Michael?
We've had a lot of successes the last year or so going into struggling plants and helping them achieve the peace of mind I talked about earlier. So we really want to extend that. So we're looking to expand our regulatory approvals across the U.S. And we also want to extend it into other markets, as I said before, like Roman mentioned, seawater desalination pretreatment is another area, certain parts of the world where it's a real struggle for polymeric membranes. And so we see it as an opportunity with our position, and also looking into the reuse markets as well.
Okay, when you say struggling plants, what kind of plants are you referring to?
Plants that maybe they have to put a extended pretreatment in to protect the UF membranes or MF membranes, events such as red tide, challenges that membrane plants face. Our membrane is more durable and able to handle the higher solids loading, but still achieve the requirements for the RO to minimize cleanings, et cetera, that extend their RO life. So we're looking to, all the things that we're achieving on the drinking water and industrial side, we want to extend into that market because we see it as a good opportunity for us.
Okay, Greg, you said wastewater, but where do you think you're going?
Yeah, right now, I mean, we have, we're in the early stages, and we've picked a couple of areas that we feel we can at least penetrate the market, which would be like the metal finishing area where there's high solid contents, oils and grease, suitable for the ceramics. Another market that we're looking at is industrial and commercial laundry facilities. We also believe that we have the potential to penetrate there very nicely. And then kind of forward thinking, our extended team, development team in Germany is working on some of the things that Manny had mentioned in his discussion, where he was talking about the process and where it was going. And so we are looking at some of those process applications, specifically one in like the pulp and paper industry where the byproduct or kind of, getting a product in that process can actually be quite a value stream. In fact, in that case, the paper itself would be disposable based off of how valuable if you could extract certain parts of that process. So we're looking into that.
Okay, interesting. So now polymeric membranes are becoming more hydrophilic, more chemically durable, more robust, longer lifetime. We were talking about this at lunch. So polymeric membranes, would you see in the marketplace? How do you compete with them? How do you complement them? What do you see in the marketplace, Judith?
Well, we don't directly compete with polymeric to any large extent because we are addressing the more complicated, difficult to treat water streams. But we can be complementary for, as I mentioned earlier, we're looking at the boiler feed as being a pretreatment to the second stage, with a two-stage RO being the first stage of that. So there are areas where we can be complementary, but we're not competing much because we have a wide pH range, very high solids that we can handle, and very difficult streams that would foul an RO quite rapidly.
Okay. Kevin, do you guys run into polymerics, see what you're looking for?
Yeah, I see it the same way as Judith. I think, we're not trying to compete directly against polymerics. There have been a few customers who, do a side-by-side comparison, and maybe in some cases on benign fluids, it could be a wash because the ceramic membrane life is long and the polymeric membrane life is also very long. So, but in general, I think that, we're trying to operate in conditions that aren't suitable for polymeric membranes because the ceramic membranes in most cases are going to be a little bit more costly.
Right, now you've mentioned you rely on oily wastewater. Do you ever see any polymerics in that space you're in?
Oh, for sure. But and there have been some recent cases where a customer, replaced a polymeric membrane with a ceramic unit. The capital cost was about the same, but he did it based on the membrane life, the long membrane life that they could achieve.
Okay. Now, Roman, being also a municipal, and
Yes.
what do you see in the polymeric space, and what do you see?
So we're also trying to target like unique applications where polymeric membranes are not used, but definitely on the other hand, we're also competing with the polymerics in the municipal side. So the major point for us is the lifetime for ceramic membranes is much greater, which is and flux. Of course, there are some drawbacks where polymeric membranes can win. But like with our advantages as a higher flux to achieve the same footprint is also good for us. I would say, we are competing with polymeric membranes. We have like several advantages. Unfortunately, on the United States market, it's harder for us to prove the concept that the ceramic membranes are better. It's hard to sell OPEX for the municipalities because for the most of the part they looking at the capex compared to the industrial market where the owners and the end users they're also looking at the operational cost over the lifetime of the membrane.
And because you're doing, like, for example, retrofits inside tanks and putting your membranes in,
Yes.
you're mainly going against the submerged hollow fiber?
Yes, Actually, if you take a look at our poster over there in that room, we have the same exact footprint as one of famous polymeric membrane manufacturer. Yes, we are competing against them.
I'm trying to help you, Roman. Okay.
Yes.
Good luck. Tobias, do you guys run into polymerics or complement them in some way?
Yes, so I would say the answer is it depends. It depends on the customer if he's willing to invest money into advanced technology and into lifetime. But if he's only looking at the capex, I don't think that we can compete as ceramic membrane manufacturer with polymeric membranes. Yeah, so we are mostly focusing on industrial wastewater and looking for niches, for example, acid and leach recovery. So we don't run as often into polymeric membranes, but yeah, we compete with them.
Okay. Michael, I know you do.
We're head-to-head, yeah. So, you know, in our case, you know, customers, you know, if they are looking at total cost of ownership, then we have a compelling case. And in many cases, they're just tired of having staff put in fibers and losing capacity, and we can come in, extend their capacity and for the same footprint, and bring that peace of mind that again, they didn't think was economically viable, but we've made it. So with regards to future developments in polymeric membranes, you know, we feel really confident about our trajectory and that our ability to compete no matter what they do.
So you're saying that your water security, because of your structure and strength of that structure, you feel confident that you can hold your own relative to polymerics?
And you know, and we've been, you know, bringing down our cost position, and we're able to get more aggressive as well. So we feel really confident about our position and our future position.
In your case in particular, for example, you have the multi-channel hollow fiber polymerics that claim no fiber failure. Are you running into those?
I suppose maybe not. Maybe with pristine waters, then they're okay. But the areas where we're winning, it is a real problem that our customers are facing. I guess I haven't come across those membranes that have no fiber breakage yet.
Greg?
Yeah, I think I'll probably echo what Judith and Kevin had said, that you know, I think for the most part, ceramics are complementary to the polymerics. To what you had asked, as far as polymerics, you know, kind of progressing in some of their attributes. Perhaps there may be a little bit more now of an overlap where it's not just, okay, polymers stop here and ceramics go here. There might be a little bit of an overlap that we see, but yeah, I mean, I think it really comes down to the wastewater and, you know, what can you provide the client as far as that total solution and total cost of solution that drives whether or not it's going to be ceramics. But it's some cases that, you know, you'll compete with a polymeric, but in most cases you're playing in an area where it's not the right fit and they can't accomplish it.
Okay. So what about regional geographic market space? For example, our company, we were in China quite a bit. Judith, are you only in Europe? Are you only in the United States? Where are you playing and what do you see geographically?
Well, we are focused on North America, but we have projects in other areas of the world as well that are more opportunistic. So we don't have strong partnerships in other areas of the world yet, but we have been in conversation with some, especially in Europe, and some in South America as well, but with a focus on commercializing closer to home for the first 8 years, and now we're been around 8 years, and so now that I've just been with the company 9 months, so
You're fine. You're good.
we've increased our pipeline by 10x, plus more than 10x since that time. So as that grows, we're seeing opportunities in other areas of the world for repeat customers and opportunities with multinationals.
Now, Kevin, you have the advantage, of course, having a French parent. What geographical space are you guys playing in?
Well, Elsys is a global company, so we have offices in China, the USA, Canada, in Europe. And because of our network, I think we're participating in projects, you know, all around the world. It seems to me that in China, you know, there's a lot of new plant construction, and in Europe and the US, you're dealing more with, you know, existing plants that want to make improvements. So the way you go about doing business is different, but there's business, you know, in all those areas. I think where we would be looking to grow, where there could be opportunities for us, is in South America, you know, where we could use some help.
Okay, Roman?
Okay, we have references all around the world, but definitely we focused on the Middle East. It's our first market where we have like the biggest references. Definitely Europe. We are very successful in China and neighboring Asian countries. I would say Singapore. And we're trying to penetrate the US market right now. We have around we don't have a lot of installations in the US. We have like around 9 installations, but we're trying to target this market heavily right now.
Okay. Tobias, you're more Eurocentric, but where do you see globally? Where do you see the activity?
Yeah, globally, I do think the most active market from our perspective at the moment is China, because the scale of application, the size of the application is just a different level than anywhere else in the world. But we are active overall, and we try not to be the one who's claiming to have every answer. So we partner up with partners who are specialists in every area or in specific areas. So we do have a network, so we can be able to work overall in the world.
Mm-hmm. Michael?
We're focused globally, though our global focus is strategic and tactical. So certain regions like the Middle East will be focused on seawater pretreatment. In Asia, we're focused on industrial applications. In the US, focused on drinking water reuse and possibly seawater desalination. So we do have a global focus, but it's kind of targeted on the drivers of that particular region.
And today, where do you see most of the activity?
I mean, there's still a lot of industrial opportunity in China that we're engaged in, and we want to extend that into Greater Asia. And we're having a lot of success in the drinking water market in the U.S. As I said, we want to extend our regulatory approvals so that we can extend those opportunities as well. Seawater is early for us. We've got some kind of key pilots coming up. We want to put together our value proposition, but you know, we'll have to see where that goes. But we feel like the Middle East is a really good play for us due to the challenges of the seawater there.
Greg?
Well, our immediate focus has been on North America. However, I believe China is probably the best market right now. And with that, I've recently been working very closely with one of the parent company's offices in China. They are about to complete a new production facility in Kunshan, China. And through this new life science and environmental group that they're developing, they've put some personnel in place over in China. So I'm really excited about working with them and developing that area because I think that has the highest potential of any area globally.
Okay, great. We have a few minutes here for the audience. Do we have any questions for our panel?
Okay, so I'm now the early R&D guy at a national lab who wants to accelerate the development and adoption of your technologies. What's your recommendation to me for the most important underlying kind of technical issues related to ceramics? Is it developing cheaper raw materials? Is it increasing yields? Is it increasing where would you recommend researchers go to help accelerate this industry?
Who's going to take that on?
Am I starting again?
This is open, okay? You're going whoever wants to answer.
What would you like us to do?
Well, so I'm an engineer, but I'm a chief commercial officer. You may have seen it like that. So I'm not as focused on R&D, but so in a practical sense, so I'm more of a practical than down into the core size.
The nerd stuff, yeah, I know.
Yes. I leave that to the PhDs. So I think that the surface chemistry is important, but understanding the ionic layer. So we're also different because we're doing ionic separation more than particulate separation like an MFUF would do. So my focus on that development might be different than some others. So I think that understanding that ionic layer better and how that can be optimized. We're doing very well on fluxes, so and permeability. I think that can be optimized, but that's more incremental. Configurations, and for us, we take a UF membrane and put additional layers on it with the DNA template for the pores. So that process of minimizing the number of layers and maximizing the tunability of it would be something that those PhDs are looking at that I think will benefit us a lot in our particular applications.
I think there's an opportunity to continue the incremental. Ceramics have high permeability versus polymeric, but increased permeability is only going to make the difference in CapEx lower. Packing more available surface area, I think, is a strong opportunity. So that in kind is probably some materials development that's required, manufacturing improvements, all of these things and incremental improvements. We feel that ceramics have come a long way. We're seeing ceramics become adopted now, head-to-head versus polymeric. We are having that success, and many other ceramic companies are, or several other ceramic companies are. So just continuing that trend, we feel that we're far away from, diminishing returns and improvement.
Anybody else want to take a shot at it?
Yeah, I think the one area I would add is some way to impart fouling resistance greater than what's available now. Judith talked about surface chemistry. So on an ionic separation, that's obvious. But when you talk about fouling, it would be interesting to have a ceramic membrane with a highly negative charge, for example, to help repel foulants, I think.
Any other questions?
My question is concerning the comments on the competition to polymeric membranes. If you look on the design of ceramic membranes, so we have tubular membranes, we have hollow fibers from I2M, we have submerged membranes from Nanostone and from Safborn. So it seems to me that we copy more or less things which are already known from polymeric membranes. Are there any ideas where we can go ahead to be the first and better than the polymeric membrane? Some ideas of a new design of ceramic membranes. Is there anything in the line?
Yeah, we recognize the way that we've packaged our membranes is probably not necessarily optimum, but what it is, it makes it easy for users to adopt our technology because we put it in a format that they are using today. But we think there's an opportunity to optimize the packaging around our geometry in the long run. But first we want to build our business, show what it can do, and then we'll have the clout to start to convert the market.
I'm not sure if changing the design will improve the product much. I mean, our design is optimal, I think, but there are definitely some areas where can we improve. One of the areas is the temperature resistant. The ceramic material itself is very temperature resistant, but if we're talking about submerged modules, we have like PU material on the sides, potting material, which is the limitation. I would say it would be nice to have to do the research, the material use maybe, or the way we're molding that to increase the temperature resistance for the module for example, oil and gas applications.
I would add one comment to that question. I think an area, a very interesting R&D area would be composite systems. Combine inorganic, organic systems, because they'll allow you, A, to manipulate the membrane performance. And if you do it the right way, you can manipulate module design. Ceramics are harder to manipulate because of all the processing steps. So I think that could be a very fruitful area for R&D, composite systems. Any other questions? If not, thank our panel.
Yes.